Let's look at this question. It is coming from a book published in 1893 by the Cambridge University Press, written by SL Loney, coming from chapter 33. DE is a tower standing on a horizontal plane and ABCD is a straight line in the plane. The height of the tower subtends an angle theta at A, 2 theta at B, and 3 theta at C. If AB and BC be respectively 50 and 20 feet, find the height of the tower and the distance CD. So let's try to visualize this one. Let's draw a simple sketch here. So there is a horizontal plane and there is a tower, vertical tower, and then the plane is horizontal plane and ABCD are the points on the plane. So let's take this as D, because this is the tower, DE. DE is the tower, so we take this as a tower and this as A. So the points A, B, C, D lie on this straight line, which is a horizontal plane. So first they say the height of the tower, say let's take it as H, subtends an angle theta at A. So that means theta is the angle that subtends when you look from point A. And we walk forward towards the tower. Then at B, the angle is 2 theta. That means we come to a point where point B, if you look at from that point, there will be an angle which is equal to 2 theta, the angle which subtends, the height of the tower subtends the angle 2 theta. Similarly, we walk closer, then at point C, we can see the point C and tower here, and it subtends angle 3 theta. Okay, this is the visual picture, and also it is given that AB is equal to 50 feet, AB, BC is equal to 20 feet. These are in feet, but if you like, you can make them meters. But let's use the one that is given in this 1893 book as it is. So now we can write few equations because we are asked to find few things, and one is CD. Let's make it as X. So we need to find this one, and we need to find the height of the tower. So using trigonometry, we can write few equations. One, we know ED divided by DA, ED divided by DA, which is equal to tan theta. This is angle theta. But ED is H, DA is equal to X plus 20 plus 50. Okay, and then we can take the other triangle, EDB triangle, in which we can write ED over DB is equal to tan 2 theta, which is equal to H divided by X plus 20. And lastly, we have this one, EDC triangle, in which ED divided by DC is equal to tan 3 theta, which is equal to H divided by X. We have three equations now, 1, 2, and 3. Now we need to simplify this equation and find the two unknowns H and X. Also t is an unknown, but we should be able to get rid of theta. Sorry, theta is an unknown, but we need to simplify 1, 2, 3 and try to get rid of theta, because that's the third unknown, which we don't need to calculate at this moment. But from the basic theory of trigonometry, we know something for tan 2 theta. So I write it in different color. Let's write this one. This is tan 2 theta, coming from your theories. Tan 2 theta is equal to 2 tan theta divided by 1 minus tan squared theta. Also, there is another equation for tan 3 theta, which is equal to 3 tan theta minus tan cube theta. Tan cube theta divided by 1 minus 3 tan squared theta. So let's take this one as equation A and this as equation B. So now we have 5 equations, and then we have 2 unknowns. In fact, we should be able to get rid of theta using all these equations. Okay, let's go to the next page. Now we have few equations. One is tan theta here, tan 2 theta and tan 3 theta. Also we have this the equivalent equation for tan 2 theta and tan 3 theta. So what we can do is we can divide, say we can divide 1 by 2. So let's try one equation one way. 1 divided by 2 will give us tan theta divided by tan 2 theta is equal to this right hand side, x plus 20 will come top, and then denominator will become x plus 20 plus 50. Okay, so tan 2 theta can be substituted from this equation. That means which is equal to tan theta divided by 2 tan theta multiplied by 1 minus tan squared theta. So we can see something here. So basically tan theta and tan theta will cancel off. We can have an expression for 1 minus tan squared theta here. So that means we can obtain, simplify here. So we write 1 minus tan squared theta is equal to 2 times x plus 20 divided by x plus 70. So we leave it there and do the same thing for equation 1 and 3. Let's do the same thing for equation 1 and 3. So that means 1 divided by 3, we get tan theta divided by tan 3 theta is equal to x divided by x divided by x plus 20 plus 50. Okay. So similarly, we can substitute for tan 3 theta from this equation. That means tan theta divided by 3 tan theta minus tan cube theta upon 1 minus 3 tan squared theta. Okay, so again we can see that tan theta will cancel off. This will give us 1 minus actually if you simplify this, we have 3 minus tan square theta here. So this equation will only consist of tan square theta. So our idea is to find tan square theta and substitute it here. So then we can get rid of theta, isn't it? So what we left with is an equation with tan square theta. So I will write it as it is: 1 minus 3 tan square theta divided by 3 minus tan square theta. Okay, so this is another equation. So we'll see that this is as equation C and this as equation D. Okay, so now we'll go to next page and see whether we can simplify further. So okay, so now we have here, so we copied the equation C and D here now. So what we need to know is how can we get rid of tan square theta. So we can actually do some kind of simplification. First one, we can actually obtain tan square theta easily from equation C. Equation C gives us tan square theta is equal to 1 minus 2x plus 20 divided by x plus 70 from equation C. From equation D, let's try to simplify further. From equation D, we can see that x over x plus 70 is equal to 1 minus 3 tan square theta divided by 3 minus tan square theta. Okay, so this one we can simplify by multiplying across. So we can see this will give us 3x minus x tan square theta equal to x plus 70 times minus 3 x plus 70 tan square theta. So from this we can write, therefore tan square theta, take one side, so will we take this one to one side, 3x plus 270, you take this one to left hand side, minus x is equal to x plus 70, we take this to the other side, minus 3x, so we get tan square theta is equal to 70 minus 2x divided by 210 plus 2x. We have this one, say equation E, and this one is equation F. Okay, so we have obtained tan square theta, and now it is a matter of simplification and find x. So if we write the equations back here again, so we got tan square theta is equal to, basically we have 1 minus 2x plus 20 divided by x plus 70, x plus 70, so when you simplify we get x plus 70 upon x plus 70 minus 2x minus 40, which is equal to 30 minus x divided by x plus 70. Okay, so from the other equation, let me go back again. So 70 minus 2x over 200 plus 2x, 210 plus 2x, so that one tan square theta is equal to 70 minus 2x divided by 210 minus plus 2x. So when you, if you equate this one, say this one, what was our first equation? Equation F, equation G, and equation G and H. So from G and H, we can write 30 minus x divided by x plus 70 is equal to 70 minus 2x divided by 210 plus 2x. So this one we can simplify. If you write cross product, I think what you can see is that 210 plus 2x times 30 minus x, which is equal to 70 minus 2x times x plus 70. So we can see actually 2x squared and 2x squared will cancel off, so there won't be any square after that. So once you simplify this one, we get 30 times 210 plus 60x minus 210x, and 2x squared cancels off, 70x plus 70 times 70 plus minus 140x. Let's try to simplify and see. Finally you get 6300 minus 4900 is equal to 80x. So therefore x equal to 1400 divided by 80, which is equal to 17.5 feet. If you have used meters, so your answer will be in meters. So then we need to find out, this is the height, this is the distance DC. So if you go back to the question, this is the one. So we found this one. This one is equal to 17.5 feet. Now we need to find h. So to find h, we need to use either of these equations, where we can use one of those equation. If you know tan theta, we can find h. So let's try to find either tan theta. Yeah, basically we can find tan theta. So to find tan theta, we can substitute values of x to one of these equation. We can substitute it here or here. So let me check. So we have tan squared theta here, so let's use this one. So tan squared theta, use a different color. Tan squared theta is equal to 30 minus 17.5 divided by 17.5 plus 70, which gives us tan theta. If you simplify this one, tan theta is equal to 0.37796. So therefore h is equal to, substitution is equal to, I think we can substitute to the easiest equation, where this equation, which is tan theta and h is given. So from equation 1, that means tan theta times 70 plus x, so which gives us 0.37796 times 70 plus 17.5 feet, which is equal to 33.05 feet, which is the distance EE in the question. So these are the two answers. So it is coming from a book published by Cambridge University Press, authored by SL Loney. It was published in 1893, so it's a very classical book. Thank you for looking at the answers.